Imagine staring into the abyss. Not just any abyss, but one so profound, so utterly alien, that it warps the very fabric of reality around it. A place where gravity reigns supreme, a cosmic tyrant from which nothing, not even light, can escape. For centuries, these enigmatic monsters of the cosmos were mere whispers in the equations of brilliant minds, a terrifying theoretical possibility. We called them black holes. Many believed they represented the absolute limit of human understanding, forever shrouded in mystery. They were dark, bizarre, and frighteningly elusive. But then, something extraordinary happened. In 2019, after decades of relentless pursuit, humanity finally captured the impossible. We got our first real glimpse. And what it revealed was both familiar and profoundly unsettling. Before that historic image, black holes existed only in complex physics equations and wild speculation. But that single photograph confirmed their terrifying reality. So what exactly is a black hole? The concept is deceptively simple, yet mind-bendingly complex. Picture a region of space-time where gravity is so incredibly strong that absolutely nothing, no matter, no radiation, not even light, can escape its clutches. Albert Einstein's theory of general relativity predicted that if you cram enough mass into a small enough space, it will distort space-time so severely that it literally tears a hole in the cosmic fabric. Please like and subscribe to my channel. Please comment what you want to suggest to me. That will be the motivation for me to make videos every day. Thank you very much. Now let's get back to the topic. What's inside a black hole? 1. The cosmic abyss. What are black holes and how do we find them? Surrounding every black hole is an invisible boundary known as the event horizon. This is the point of no return. Once anything crosses this threshold, it's gone forever. The reason they're called black is because they absorb all radiation and matter that passes the event horizon, like a perfect thermodynamic black body. It's not that they're empty, but rather that the gravity is so intense that light can't reflect off them or escape from within. While they share the same fundamental properties, black holes come in different sizes, reflecting their diverse origins. Think of them like a family, each member with its own unique story. First, we have stellar mass black holes. These are the most common, typically about 10 times the mass of our Sun. They're born from the catastrophic collapse of massive stars at the end of their lives, when the star's core implodes under its own gravity. It's like a cosmic death rattle that leaves behind a super dense remnant. Then there are intermediate mass black holes. These are the teenagers of the family, falling somewhere between stellar and supermassive black holes, with masses ranging from a few thousand to a million times the Sun's mass. Scientists are still actively debating how these mysterious objects form, but they might be the result of multiple stellar mass black holes merging, or perhaps the rapid growth of stellar black holes in dense star clusters. It's one of the biggest puzzles in astrophysics right now. And finally, the undeniable titans, supermassive black holes. These behemoths are the heaviest in the universe, weighing millions to billions of times the Sun's mass. We believe they reside at the heart of almost every large galaxy, including our own Milky Way, which hosts Sagittarius A*. How do they get so big? Current theories suggest they might form through a unique mechanism, such as the merging of galaxies, which brings their central black holes together, or perhaps from the direct collapse of massive gas clouds in the early universe. It's like the cosmic equivalent of two cities merging and their respective city halls, becoming one giant superstructure. So, if black holes are fundamentally invisible, how do we know they're there? It's not like we have a giant cosmic flashlight. The answer lies in their interactions with their surroundings. While the black hole itself is dark, The matter swirling around it often glows intensely. Imagine a bathtub drain. As water spirals down, it picks up speed. Now replace the water with gas and dust, and the drain with a black hole. As this matter gets pulled in, it forms a rapidly spinning disk called an accretion disk. The intense friction and compression heat this material to millions of degrees, causing it to emit powerful X-rays and other forms of radiation. This makes the region around the black hole one of the brightest objects in the entire universe. It's like finding a light switch for something inherently dark. Astronomers also detect black holes by observing their immense gravitational influence on nearby stars and gas clouds. If a star is orbiting an invisible object with incredible speed, we know there must be something massive pulling on it. For example, by carefully tracking the orbits of stars at the center of our Milky Way, astronomers calculated the mass of Sagittarius Asterisk to be about 4.3 million times that of our Sun. It's like watching a figure skater's partner unseen, but knowing they're there because of how the skater moves. 2. The ultimate demise. What happens if you fall into one? Let's get to the chilling part. What if you fell into a black hole? Forget the Hollywood depictions of wormholes or quick escapes. The reality, as physics describes it, is far more terrifying. A common misconception is that black holes are like super dense, solid objects. While they form from incredibly dense matter, the black hole itself is just empty space-time, a region where gravity has become so strong it creates a void. Think of it this way. If our Sun, which has a diameter of 1.4 million kilometers, were somehow compressed into a black hole, it would shrink to a mere 6 kilometers across. But from far away, its gravitational pull would be exactly the same. The danger only comes when you get incredibly close. Let's imagine you're on a cosmic journey, an unwitting adventurer approaching the event horizon. You might not even realize what's happening. The first thing you'd experience is the bizarre distortion of light around the black hole. It acts like a cosmic funhouse mirror, bending light from distant stars in impossible ways, creating strange, warped images. But the real horror begins once you cross the event horizon. At this point, escape velocity exceeds the speed of light. You are now irrevocably committed. There's no turning back. Even if you had a spaceship with infinite fuel and an engine that could defy known physics, you couldn't outrun the inevitable. And then comes the truly gruesome part: spaghettification. This isn't just a sci-fi term. It's a real consequence of extreme gravity. Imagine approaching the black hole feet first. The gravitational pull on your feet would be significantly stronger than the pull on your head, because your feet are closer to the black hole. This difference in gravitational force, called a tidal force, would stretch your body vertically like a strand of spaghetti, while simultaneously compressing you horizontally. Your limbs would be torn from your body, and your atoms themselves would be ripped apart, dissolving into fundamental particles. You would literally cease to exist as anything recognizable. It's a grotesque, unimaginable end. As you undergo spaghettification, something else bizarre is happening: time dilation. For someone observing you from a safe distance outside the black hole, your clock would appear to slow down drastically. The ticks of your watch, your breaths, even your thoughts, would seem to drag on almost infinitely. To that distant observer, you might never actually cross the event horizon. You would simply appear to freeze at the edge, fading into oblivion. But for you, the unfortunate traveler, time would feel perfectly normal right up until your demise. This is because you and your internal clock would be synchronized with the local spacetime, which is slowing down relative to the outside universe. And what waits at the absolute center of a black hole? The singularity. This is a point of infinite density and infinite gravity, where all the mass of the black hole is concentrated into a space smaller than an atom. Our current laws of physics completely break down here. It's a region where space and time cease to have their usual meaning. We simply don't have the tools to describe what happens at the singularity, or what becomes of the matter that falls into it. Does it disappear entirely? Does it transform into something else? This profound mystery only deepens the allure and terror of black holes. 3. Beyond imagination. Black holes, the multiverse, and time itself. Now let's dive into some of the wildest, yet most compelling, theoretical implications of black holes. What if these cosmic devourers are actually cosmic creators? One fascinating idea, popularized in films like Interstellar, suggests that black holes might be gateways to other dimensions, or even other universes. Physicist Kip Thorne, a scientific advisor for Interstellar, explored the idea of black holes leading to a 5-dimensional bulk space. The theory proposes that matter doesn't just vanish at the singularity, but might land on an internal surface within this higher dimension. Imagine our universe as a sheet of paper. A black hole might punch through to another sheet, or perhaps fold the paper in on itself. Even more mind-bending is the black hole universe hypothesis. This theory suggests that our entire universe could exist inside a black hole, which itself is part of a larger universe. If the Big Bang, the event that created our universe, started from an infinitely dense point of singularity, could that singularity have been the core of a black hole? It's a provocative thought. If our universe is constantly expanding, and a black hole continuously draws matter inward, how could our universe be inside one? Well, the theory suggests that as a black hole draws matter in from its parent universe, the interior of our universe, the black hole's interior, would expand. This could potentially explain one of the biggest mysteries in cosmology: dark energy, the unknown force driving the accelerating expansion of our universe. What if dark energy is just the result of matter from outside our black hole universe being pulled in and converted into expansive energy within? The implications are staggering. If every black hole contains its own universe, then the cosmos isn't just vast. It's an infinite fractal structure of nested realities, a cosmic tree with branches upon branches. While the largest known black hole, TON 618, is still far too small to contain a galaxy, let alone our universe, the universe itself is curved and potentially infinite. Perhaps our universe is the interior of a black hole, and we are simply unable to perceive its boundaries from within, just as we can't reach the center of a black hole. Beyond their role in cosmic creation, black holes also offer a tantalizing, albeit theoretical, pathway to time travel. As we discussed with time dilation, clocks near a massive object run slower. This effect is extreme near a black hole. A year spent near a black hole could translate to 80 years passing on Earth. This means, theoretically, if you could fly close enough to a black hole without crossing the event horizon, you could effectively fast forward into Earth's future. You'd return to a world that had aged far more than you had. It's an incredible thought, but as we know, the engineering challenges of getting that close and escaping are currently insurmountable. No known spacecraft could withstand or escape such gravitational forces. What about traveling to the past? This is where it gets even more speculative and truly mind-bending. Some theories suggest that black holes might warp space-time into a closed time-like curve, essentially a loop in time. If you could enter such a loop, you might find yourself traveling backward through your own personal past relative to the black hole's formation. However, this is even more hypothetical and comes with major paradoxes, like the grandfather paradox, and would still require speeds faster than light. So while the idea of visiting dinosaurs is a fun thought experiment, it remains firmly in the realm of science fiction for the foreseeable future. Black holes remain one of the universe's most profound and terrifying mysteries. Our understanding has advanced dramatically, from pure theory to capturing their actual image. Yet, we've only scratched the surface. Scientists worldwide are tirelessly working to unravel their secrets, hoping to unlock deeper truths about space, time, gravity, and even the very origins of our universe. The journey to fully decipher these cosmic monsters will undoubtedly be long and challenging, filled with more questions than answers. But every discovery brings us closer to understanding the fabric of reality itself. The lesson of black holes isn't just about their destructive power, but about the incredible resilience of human curiosity. They push the boundaries of our understanding, forcing us to confront the limits of physics and inspiring us to imagine realities far beyond our current grasp. They are cosmic laboratories, testing the very fabric of existence and revealing how little we truly know. In a way, black holes are not just terrifying voids, but cosmic mirrors, reflecting our insatiable desire to understand the universe and our place within it. Do you think studying black holes is worth the immense effort and resources? Could unlocking their secrets truly usher in a new era of scientific understanding? Let me know your thoughts in the comments below.